Okay, welcome to our demonstration of the loading device that's going to be used at the Pacific Northwest Regional Conference. We're going to start out with about 3,000 plus pounds of weight that are resting on two support frames that we'll be pulling against with pneumatic loading devices. And here's one of the support frames under the back span and the one that we would put under the cantilever. This one's adjustable, and we'll talk about that later. The bridge we're using here is a couple years old and doesn't have the cantilever in, but it's good enough, I think, to demonstrate what's going on. The piece of plywood on top represents the grating that will be used. We'll actually be using a plywood grating on this for the competition. And there's another close-up look of the cantilever and support, which has to be adjustable because the load is somewhat adjustable from bridge to bridge. The crossheads now are then placed on top of the grating. This picture shows the backspan crosshead. It has 8 pneumatic rams. So does the cantilever crosshead. The backspan one has 2-inch diameter rams. The cantilever has 1.5 inches because of the difference in loading that we have. All connected by a common pressure hose, so every ram has exactly the same pressure on it. They are held down to the loading frames at the bottom, and they with 4 all-thread rods. So the crossheads actually work against that. A pressure tank is pre-charged to the correct pressure before the pressure is added to the rams to prevent an overpressure situation. We'll show this in more detail in a moment or two as well. Alright, to show you how this is done and connected, the crosshead is placed on top of the grating, and preload goes on that plywood on top of the crosshead, which we're not showing in this video. And then the judges will go and place in the all-thread rods, which go down to coupling nuts, and hence engage the loads. Once they get this done, they'll go up and adjust the nuts at the top of the thing so that there's about a 1/4 inch of play for the rams to be able to work against this. When we do this, only the backspan is done first. The cantilever end is not installed so that it can actually deflect upwards during the first load stage. So that's about how long it takes. Drop the rods in, connect them, everything's pre-positioned according to the roll of the dice the night before. This is another look up the whole setup. You can see the steel resting on the base, and it never leaves the ground, and the loading steel never moves. Then we have the plywood decking, we have the crosshead on top, and the rods that hold it down, and then the pressure line going to the pressure tank, which has a very precise and accurate Omega pressure measuring device mounted on it in order to get the pressures that we need. Now, we have calibrated the pressure heads, the cross heads, and these pressure tanks and the gauges, lifting known weights, and in order to get a calibration factor. And hence we've been able to figure out exactly the pressure that needs to be applied to reach the competition load. The next stage here's another view of the cantilever end. And what you'll notice is the cantilever end can be different for every bridge, so we have to be able to position that load any way we can. So the weight on this case is actually sitting on a small platform, and then we can move the part that engages the crosshead to match whatever the bridge can accommodate. Finally, let's take a look at the pressure situation. These pressure tanks, we have a large one for the large crosshead, or the backspan crosshead, and a smaller one for the cantilever, can be pre-charged to the pressure that is required. For the backspan, we've calibrated this needs to read 70.9 psi. It turns out that we pre-charge the tank, and then when we open the valve to pressurize the crossheads, this pressure will drop. And so then we'll come back and top off the pressure in the tank with the compressor until we get exactly the pressure that we need. In the background is our deflection measuring device, and we'll talk about that in a minute. But here we go. He's trying to get that up to about 70.9 plus or minus a couple, about 0.2 or 3 psi. And we can get pretty close, and it holds the pressure pretty well. Once we do this now, we have a valve that is slowly opened by our judges, but it applies the pressure in a matter of a couple of seconds to the bridge. So this is why we don't want anybody near the bridge, and this can be done from quite a distance away. So here she goes. Maria will turn the valve, and you can notice the pressure drop in the tank. It drops about 4 psi. So it's less than competition weight right now, but our judges will now add pressure to reach the competition pressure and its equilibrium state. And the pressure gauge being somewhat near where the pressure is put in, then it does vary a little bit, but we get it to an equilibrium state. Deflection measurement is also simple and different than what you're used to seeing. We have a separate piece of wood that crosses the bridge and will be clamped to it on the day of, and that has a hook on the end to which we attach a chain. This chain, as we go down, is connected to some steel fishing leader and goes down to a 25-pound steel block, which will not move under about the 5-pound pressure or tension on this wire, and it passes through a fishing eye that is glued to the top of the steel block. And then that runs to some distance away from the bridge, so the deflection measurement can be taken without anybody getting near the bridge. Runs through a fishing eye, and then we have a plexiglass holder that holds a 3x5 card that will be taped in place. And the measurement is done by marking where that angle goes. But anyways, that angle is held in place with a tension spring that adds about between 5 and 10 pounds of tension to the whole system. And that's a constant tension because over the deflection of the device, or at least it's a very small difference. So once everything is in place and the proper load is applied, and she'll actually run the pencil up, that's how we intend to do it. And the edge there has been ground, so it's kind of a knife edge, by the way, on the angle. We'll mark the initial place and then later come on, and after each load stage, mark each additional device. So as the bridge deflects, the angle moves rather precisely, and then another mark is made. And so you'll end up with 3 marks on the card at the end, and the deflection is measured with a caliper that goes to the nearest thousandth of an inch, which is better than the national competition, which measures to the nearest 7/1000th of an inch. Sway measurement is also different this year. We're not going to use a plumb bob. We find them difficult, so we found some ground-mounted lasers. That's that gray thing on the ground there, which actually has a motion sensor, and these are used for positioning cars in garages. And we've created a target which is also on a separate piece of wood that will be clamped to the bridge, and it can be centered the target we will put on one corner of the laser beam, and we'll move that. That first circle is a 1/2 inch diameter. We'll see that again. And so you'll be able to see when it moves the 1/2 inch and when the laser goes out of bounds, then you're okay. The thing about our loading device, the one thing it does do, it does restrict sway just by the nature of its design. So we anticipate a lot less sway than what you would see during vertical loading at the national competition. It's just by nature of the rods that go down to hold it. Anyway, so that's our sway measurement device. So anyways, if you have any questions about this, you can send me an email. There it is. I'm on the National Rules Committee too and can answer the